Hi, in this series of video tutorials in Hive, we'll cover Hive right from the basics to the advanced. Basics of the structures that are used in Hive and how to use Hive. Then we go on to the advanced topics in Hive, where you'll see how to optimize so as to get the best performance out of Hive. Okay. Then we look at the prerequisites. If you have a basic understanding of HDFS, that would be great. MapReduce will also be helpful. Now, if you do not know MapReduce, do not worry, because when you use Hive, you actually do not use MapReduce at all. Okay, but if you do know, you'll get a better understanding of how things are happening behind the scenes. Okay. As we progress through the series, there'll be a few data files that I'll use to show you some demonstration and things like that. So wherever necessary, Intellipaat will provide you the data files. Okay. Then if necessary, I'll also provide some links to some external websites. Now, for the purposes of demonstration, I'm going to use the Cloudera Kickstart VM. This VM comes packaged with the entire Hadoop ecosystem in there. It has got HDFS, MapReduce, Scoop, Hive, Pig, you name it, and everything is in there. Okay. When we come to doing a demonstration of what I'll do at that time is I'll show you how to use Cloudera Quickstart VM. Okay. Right. Before we start this video session, let's have a look at the complete course content. So in the first video, we'll look at introduction to Hive. What is Hive? What are the basics of Hive? Then we'll look at schemas in Hive. We'll compare it to traditional RDBMS. Then we'll look at difference between Pig and Hive. The most common use case in Hive. And then we'll get our hands dirty by interacting with the HDFS, and also we'll see the basics of what happens when you interact with Hive. Okay. The next video will be on relational data analysis with Hive. Here you will see how you create databases in Hive, tables in Hive. Then you look at some basic SQL Hive query language syntaxes. We'll look at some data types. We'll join two data sets as well. Then commonly used built-in functions, and we'll do some hands-on exercises. Okay, these hands-on exercises, I'll show you some examples every time I speak about a concept. Okay. The next part will be data management. We'll look at different kinds of tables in Hive. There are a couple of them. One is self-managed or Hive managed tables, and there are external tables. We'll see what's the difference between these two, and when and where can you use these things. Then we'll look at how to create views in Hive. We'll also look at how you can store the results of the queries that we run in Hive. Okay. Further on, we'll look at optimization. Now, you run queries. Like in SQL, you run queries. Now, when you run queries, the query optimizer gives you the best possible plan. Now, this plan depends on how the tables are partitioned and things like that. So we'll do something similar. We'll try and partition the tables. Then we'll look at indexing and a concept of bucketing, which is new to HiveQL and which is not present in SQL. Okay. Then we look at extending Hive. Hive provides some extension points. Example, say you want to create a function which returns a hashed value or an encrypted value of a particular string. Say example, you have a username and password in your table, and the password you would never want to make it visible to people. So you want to create an encryption for that password. So there may not be a function which does that. So what Hive does in this case, it allows you to extend Hive. There are some extension points in Hive where you write your program. I'll show you how to write code in Java, and you hook it into Hive. Once you hook that into Hive, you can use it as a normal function. Say select of upper of this string from my table, things like that. Okay. Then we look at various tips and tricks, various environment variables that you can use to optimize Hive. Okay. Right. So let's get going. Now, what we'll do right now is, in this session, since it's an introduction, I just want to do a brief recap of HDFS MapReduce. Okay. Now, most of you might be knowing what HDFS is. It's a Hadoop distributed file system. It is fault tolerant, reliable, etc. It gives you some kind of a replication and stuff like that. Okay. You know MapReduce as well. If you do not know, I'll just open up a little diagram it's a picture. Now if you can view this picture, this is a very quick architectural diagram of HDFS and a MapReduce. Now all of you know how this thing works. So if I just say HDFS, you have the name node and you have the slaves, which are data nodes. The data is present here. Okay, so these are data nodes. Now name node has got all the meta information of all the blocks of a particular file. So the name node knows where the file blocks are stored. Okay. Now MapReduce is a computational framework. Okay. So what is it? It's a computational framework. Which leverages this HDFS architecture. MapReduce is parallel processing. It has got two daemons in there. It has got a job tracker and a task tracker. Now job tracker, it queries the name node. Say example, I have a huge file called F1, and F1 is broken down into a few blocks, say A, B and C. Okay. So because name node knows where A, B and C are, let's say they are here, A, B and C, these blocks. The job tracker, if I want to run a MapReduce program, I submit the code and the job tracker takes over the responsibility of analyzing the data. Say, suppose for example, I want to find out how many times the word what is in this big file. Okay, this is just a simple example. So what MapReduce does, it takes advantages of this HDFS framework. Now the job tracker will retrieve all the information. It knows where block A is, block B and so it will run the tasks on those particular nodes, and then it will do an aggregation, and then in the end there is something called as a reducer which will do a summarization. So the job tracker and the task tracker together will do the job for you and give you this output. Say what is repeated, say 25 times in this entire file. So that is what is MapReduce. MapReduce, it leverages or it takes advantage of the HDFS architecture and is a computational framework, okay, which does parallel processing. Okay, so that's what an HDFS is and what MapReduce as a computational framework is. Okay, so that was a brief recap. All right, so let's go further. Now, since we have come to Hive, what does Hive offer to you? Now, if you have a very large data set and you want to analyze the data, now the first thing what you would be doing is you will go here. Okay, you'll say suppose this is a very large file. Okay, a large file called F1. Right now, your boss comes in and says, okay, find out all the people who have spent more than $5,000. Okay, from this file. This is a data set. Now the first thing that will come to your mind, okay, MapReduce. But to work with MapReduce, you need to have some expertise in Java or any other API that supports MapReduce, correct? So you need to have some expertise, and MapReduce is not easy to program. It is a bit difficult, correct? So that is the first thing that you will do. Now, since it is a huge learning curve to learn MapReduce and then analyze the data, Hive comes to the rescue. So Hive has come to our rescue. Now what is Hive? Hive is SQL for Hadoop. So what do we mean by Hive is SQL for Hadoop? Before we go there, let's do something. Okay. Now Hive was created at Facebook. Now, Facebook had a large pool of engineers who were well versed with SQL, and they wanted to use this SQL knowledge rather than you know, make all the engineers learn MapReduce. So what they did is they built an engine. They said, okay, let's build an engine that will convert SQL queries into MapReduce code. So that's how Hive came into existence. So Hive basically, you write an SQL like query which gets converted into MapReduce code. Okay, so that's what Hive is. Now that is what you can do with Hive. Now if anyone asks you for a definition of Hive, you can say Hive is a data warehouse infrastructure built on top of HDFS. Okay, so in the previous statement I said there is a Hive engine, you write an SQL query, the Hive engine converts everything to MapReduce. Now MapReduce, where does it run? It runs on HDFS. So you can safely say that Hive, is a data warehouse infrastructure built on top of HDFS. Okay, so that is what Hive is in one line. So this is what you do. Want to leverage Hadoop stack and technology to do warehouse and analytics. Okay, so this is what we covered. It's a Hadoop based system for querying and analyzing large amounts of structured data. It uses MapReduce for execution. It uses the underlying HDFS storage. Okay, now what's a typical use case? Typical use case is what I think we already discussed. Was a typical use case. We said we have a large amount of data. Say, let me draw a file. So we have a large amount of data, large data file, say 10 gig file. And we want to analyze this data. Now, as I said, MapReduce needs expertise. And in your place of work, you have business analysts who do not know MapReduce. Business analysts, some of the business analysts may know SQL. Right? And you have this large amount of unstructured data. What do the business analysts usually do? They run aggregation, summarization, functions on tables, etc. Correct? Then they do data analysis and then they analyze the data based on the above, and then they will have some pictorial representations like a bar chart like this or a pie chart like this and stuff like that. Okay, so they'll have this kind of things. This is the kind of things they do. Okay, so the typical use case is to place this large amount of unstructured data into some kind of a structure and allow the business analyst to run aggregation, summarization functions or queries and then analyze the data. So that's a typical use case. This is how you would use Hive. So large amount of structured data, we have to somehow give it some kind of a structure which will allow the business analyst to use these tools. Okay, so that's a typical use case. There you go. That's what is explained in that slide. Now, when will you not use Hive? Okay, for that I'll explain when will you not use Hive. Okay, let's say rather than just giving a statement, okay, don't use Hive in this case and don't use Hive in that case, we'll go back to the basics. Now, if you look at it, this is, let's say this is the HDFS system. Inside here, you have the name node, the data node, data node, the job tracker, the task tracker, okay, and they communicate this way, okay. So this is a HDFS system. Now when you and you have a huge file here, say this is file F1, okay. Now when you have this file F1 here and you write MapReduce code, MapReduce takes a very long time to run. So the latency is an issue. So you wouldn't use MapReduce when you have online transactional processing. Say you are on a website and if you want some data out of that system very quickly, you wouldn't be running MapReduce on this large amount of data and expect the user to still be there till the result comes back. So latency is an issue, and MapReduce you can't use it on OLTP, online transactional processing. So based on this, because Hive converts everything to MapReduce, it automatically means that Hive is not suited for online transactional processing. Correct? So that is point number one. Hive, where latency is very important, you cannot use Hive. Second, now I said Hive is SQL for Hadoop. Okay, we'll come to this again. When I said SQL for Hadoop, it means it has got tables, it has got views, etc. So does it mean that it will allow you some kind of crude kind of an application? No. So even a crude application is not possible, because by the very nature of HDFS, what is the nature of HDFS? It is write once and read many a times. So if I write this file once, I have to read this many a times for analysis. Correct? I can't be using this for finding a particular piece of data in there. Say a small chunk of data. Say find this. Even to write some find, I'll have to write a MapReduce code, which will take a very long time to run because it involves creating mapper task, reducer task, etc., and firing up the JVMs and things like that. So crude kind of application, you should not use Hive because it's impossible. Okay. Also, when you have a very small data set, you'll be better off by writing MapReduce at that time, because the amount of infrastructure involved in creating in setting up Hive, having an RDBMS to store meta information and things like that. So all of that wouldn't justify. So you rather do MapReduce, and even MapReduce is not the right thing to do. You might use some other tools for extraction data, because by the very nature again, HDFS is for large files. Default block sizes in HDFS are 64 MB. Now if you have very small files, the name node will be storing a lot of meta information and this will get heated up. So again, for small data set or for small files, this is not very useful. Okay, so by the very nature of HDFS, all of these things cannot be done in Hive. Okay, let's go back to the PowerPoint. Okay, so here we go. If we need response time in seconds, that is latency. You do not use that because behind the scenes MapReduce is run. If data does not cross GBs, and if we can't provide a structure to it. As I said, the typical use case is to get unstructured data and give it some kind of structure, okay, which allows the business analyst to run their queries. Now, let's go to this next thing. Since we know we have a little idea about Hive, we'll try to get into the details of Hive now and what RDBMS does, what Hive does, what Pig does, okay. Let's have a look at some RDBMS concept. Okay, let's look at some RDBMS concept. Now, In an RDBMS, a typical, say the simplest form of use case, you as a user, you're using some kind of SQL tool and you want to insert this data. What do you want to insert? You want to say insert into employee table. What do you want to insert is say employee ID John and salary of 3000. Okay. What happens when you do this? When you do this, this query gets into the RDBMS world. It gets into this environment. Okay. So for this to happen, what you should be having? You should be having an employee table, correct? So you'll be having an employee table like this. A schema for the employee. You'll have say ID is number, comma name is varchar2, and say salary is a number. Okay, the simplest form, right? You'll have something like this. Now the moment you write this query and say do this, this particular data will be checked against this. This one will be checked against this, and this one will be checked against this. When these conditions are satisfied, only then the data will be persisted. Now this is meta information, correct? So even though it is a schema, it is some kind of a meta information. Like what kind of data should be persisted? Of course, this is connected to a lower level binary file in there, which this will be stored as zeros and ones. Okay, so that particular row will be stored like that. Of course, when you read it, you will get a representation in a human readable format as 101 John and 3000. Okay, so this is what you get when you read, but internally it will be stored something like this. Okay, so here we have a schema and we do an insert. So when we have a schema already, it is schema on write. Okay, we have a schema already and we are writing it. So the schema checks against all the data types and allows the data to be inserted. Now this is the RDBMS world. Okay. So what do we have in Hive then? As we discussed, our use case was we have a large file, and this is the HDFS, this is the Hadoop system where we have the name node and the data node, and here we have a large file which is already ingested called employee dot text file. Okay, and this employee dot text file has got data like this, John and 3000. So this is a large file inside HDFS. Okay, now we want to query this file or we want to analyze this file. So as we discussed before, we can use MapReduce. That is good, fantastic, but we do not have any Java knowledge in our company. So what is it? So Facebook, as I said, they developed this software called Hive, which sits on top of HDFS. Now if I want to query, if this person here wants to query for employee ID 101, how would he do that? As I said, he can always write MapReduce, but no. So there is something missing here. What is it missing? It is missing a schema. Right? A schema is missing. So what we do in Hive is we create a schema. Then we'll say ID is int, comma name varchar2, and salary is int. So we create a schema. This schema the schema that we created, we attach it to this particular file. So this schema is attached to this file so that the schema will read in things like this and that particular order. Now it is as simple as querying this, correct? So I can say select star from employee where ID is equal to 101. So what Hive would do is it look at the schema, it look at the data file, it will run MapReduce at this lower level and give you this data out, right? So what was the thing that was missing? A schema was missing, and we created a schema. Hive asks you to create a schema. If we go back to the first thing that we, the typical use case I said, unstructured data, this is unstructured data, we have given it a structure by defining a schema. So we have given it a structure here. So unstructured data, we have given it a structure by defining a schema, and we allowed the business analyst to run an SQL like query. And internally what happens, this guy doesn't want to know at all. He just wants to get the result. So Hive asked us to create a schema, and we point that schema to this particular file. Okay. So when the schema was missing, right? In such a scenario, it is called schema on read. It was not a schema on write because this data was ingested without the schema. We created the schema and pointed that schema to that particular file location. So Hive is schema on read. Okay, so this is Hive. And in short, this entire picture is what Hive is all about. Hive wants you to create a schema and point it to the location of the data file. So create a structure for some unstructured data and then use an SQL like query to query the data from the system. Okay, so that is what Hive is. We'll look at some features of Hive. Now as I said, SQL for Hadoop. So the moment you say SQL, what does Hive support? Hive supports SQL 92 query specification. So HiveQL is based on this specification. Okay, Hive query. So it is as simple as select star from employee or my table. It is a query. Hive query is exactly the same, and they are based on SQL 92 specification. So when you have queries, it means Hive supports the concept of tables. It will also support the concept of views. When we have tables and views, you are sure to have joins to join two tables, correct? And when you have tables, you can also safely say you'll have rows and columns. Views, restricted view of a few tables together. A few tables or one table. Okay, so as I said, joins will be supported, then indexes will be supported, and so on and so forth. Okay, so these are the features of Hive. Hive supports tables just like SQL, supports views. Okay, it does support indexes, joins, rows, columns, etc. Right? And we saw what Hive does. Hive allows you to create a schema for data which is already ingested, and Hive is schema on read. Okay, if you go back to this one, schema on read. Now this data and this schema is completely decoupled. Okay, so let's, in another slide, let me type something. So Hive table. So what is a Hive table? in Hive table has got some data. Data. This is nothing but files in the HDFS system, and Hive has got schema which you created. It's schema on read, meta information, above files. Okay, so some kind of meta information. So mind you, the schema points to location of the above files. Okay, only then it will know, okay, the schema is for this particular file, and these two are completely decoupled. It means you can delete the data or you can delete the schema. Now there are some differences in there, but for now let's say you can delete the schema, or you can delete the data, or you can create the schema, or you can insert the data later on as well. Okay, but it won't be checked against the schema. If you ingest data after the schema is created, it won't be checked against the schema. Okay, again let me reiterate, it's schema on read only. Okay, so no checking is done against the schema when you're trying to ingest the data or when you're trying to save the data into the HDFS file system. Okay, so no type checking is done there. So that concludes this session on introduction to Hive. Okay, I hope you enjoyed it. Thank you.